Hello, everyone, and welcome. Thank you all so much for joining us today for this live stream event. My name is Alexia, and I am the program manager of the Microsoft Reactor Toronto. I will be sharing session resources with you in the chat, but before we begin, I'd like to quickly review two items, our code of conduct and event guidelines. First, please take a moment to review our code of conduct. Microsoft Reactor seeks to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. And secondly, our event guidelines. This session is being recorded and will be available on demand through the Microsoft Reactor YouTube channel in about 24 to 48 hours. If you have not been on a live stream through YouTube before, please note that you must create an account on YouTube in order to have access or interact in the chat. You can set that up now, and if you're unable to use the chat but have questions, feel free to reach out to us through social media or on our website. Which brings us to today's session. I'm going to bring in our speaker here for today. Wagner, hi, how are you?
Hello, Alexia. I'm fine, and you?
Great. Thank you for being back at the Reactor. We're very excited for this session.
I appreciate the invitation. Thank you.
Take it away.
Okay, guys, so let's get started in here. This is an introduction to using Terraform to deploy Azure resources. And as I am a data engineer, I will focus on the data resources we have in Azure and show you a simple script to get the things done, okay? I would say this is a level 100 presentation where people that are already skilled with Terraform won't see too many new things in here, but I would like to help people that are starting their way and get some detail on this. Okay, so let's get started. My name is, first a brief presentation. My name is Wagner Cavellini. I'm from Microsoft Brazil. I'm a senior consultant there. Actually, I work nowadays as a data engineer in there. And I'm also a columnist in several tech portals here in Brazil and also abroad in international portals too. So let's go. Our agenda, please. Let's check once again. Okay, now we're good. Our agenda will present some concepts of Terraform and how to work with it. And we also have 3 demos during following up the development of all those concepts, okay? If you have questions, I won't be able to see all to follow the chat here, but Alexia is there and may interrupt if needed. If otherwise, I will answer in the end. So let's get started. I have to run with things a little bit because it's a kind of a long presentation, and I expect to cover all the aspects I would like to share with you. First of all, for those who have no experience with Terraform, Terraform is a product, let's say, from HashiCorp. Its use is growing very fast, and I believe there are some important reasons for this growth. Okay, one of them is that Terraform uses a language that is declarative. You avoid the excessive details in there. You can control consistency of your deployments. It's idempotent. That is, if you run again, you will deploy your objects. If you run the second time with nothing changed, there will be no effect over your created resources and things like this, okay? A major topic on this is that Terraform is agnostic. You can use the same Terraform for whatever cloud provider you want. So you can use with Microsoft Azure as much as any other cloud provider. And there's another point that Terraform is open source, so there are community contributions for this framework, let's say, and things are getting developed in a very fast pace. So let's move on. Basic things about the Terraform, the work you have with Terraform. First of all, you have to install in your laptop, and you have to know the basic commands to use with Terraform that are listed in yellow in there. As you can see, you initiate Terraform, then you can validate your scripts. You can plan your deployment. This is optional but recommended step to execute. Then you can apply your scripts and deploy the objects you want, the resources you want. You can also destroy the resources you did as a rollback, for instance, and you can show what you have deployed using Terraform shell. Okay. Moving now to talk about the scripts you run with Terraform. When I mean you're deploying something, you're applying a script you have written before. And these are some important topics to keep in mind. You can create those scripts either in JSON or the HCL language, that is a HashiCorp language used by Terraform. I usually use this HCL because it's not that complicated, and you avoid a lot of information you need to repeat in JSON configuration, okay? Another point is that once we're gonna focus on Azure resources in here, our major provider for our script will be Azure RM. And you have the link to download this provider and see the documentation and to see how to use it. The idea behind the HCL scripts is to use parameters and pass values to your parameters so you can deploy your resources with the characteristics you like, the name, the SKU, whatever. You can do whatever you like with this, and I will show you some examples for that, okay? And when you deploying multiple objects, multiple resources, keep in mind that those deployments will run in parallel. This is awesome to shorten the length of the deployment process, but there are some complications when you have dependent objects in here, and we'll discuss this later in this presentation. Okay, so now let's go to an example of those Terraform scripts. The most basic script you can figure is one like this. First, you declare the provider you're going to use. In our case, is HashiCorp Azure RM. Then I am telling which versions I could use, which Azure RM versions I can use for this deployment. And here I'm saying that I can use any one above 3.0.0. Okay? And then in the other block, you will identify the resource you want to deploy, the parameters you need to pass to define this resource, and the values you want to use for them. Okay? So this is the basic idea. I am deploying here a resource group, which in my code is called RG. For this RG resource, I am passing the name of the resource group and the location where this resource group is going to be created. Next question is, how can I say this resource demands those two parameters? That's a very important subject. And you have this link in here to see the structure and the syntax required for each resource you want to deploy in Azure IAM. This is specific the case for the resource group, but you can do the same research and find for SQL databases, CosmosDB, Databricks, Synapse workspaces, and things like this. Storage accounts, data lakes, and whatever. So this is an important link you have to keep in mind to start working with Terraform. Okay, and how do I apply this simple script I'm showing in here? This is the basic idea. You go to the path where your scripts are located, connect to your Azure account. If necessary, you set the subscription you want to use, because if you have more than one, then you initiate the Terraform environment, validate your scripts, plan, and finally apply your resource. This is the basic process we do for applying a resource. So now let's go for a quick demo, the most simple one we have for this presentation. Let me go to our VS Code. Okay. This is my example one in VS Code. I created a single script called main, and this is the entire content of our main TF script. I am informing the required Terraform provider I want to use, which is Azure RM. If I want to pass extra information, I can pass this block in here and see which tenant I want to deploy my object, to which subscription I want to do that. But in this case, I kept it empty because I'm using the default values associated to my own login. And then I pass the values to deploy your new resource. I will change this one. This won't be Wagner resource group 2, but will be Wagner resource reactor 2023 10/17. The day we have today. Okay. Control S. I save this script. Now I'm going to deploy it. Okay. CD example 1. Easy login. This is why I avoid the online presentations, because sometimes it takes too much time to do some very simple things like connecting to Azure. But anyways, I think this won't be an issue in here. Once the login is finished, I will do the Terraform init to initiate the Terraform. It loads my Terraform, and the scripts that are available in this folder. This folder I am using now. And once it's okay, I can validate my scripts and then apply my scripts if I like. So Terraform validate. It's funny because pretty simple things may sometimes take too much. Okay, Terraform apply my main TF script. Let's go. It will validate my script, plan the execution, and then ask me for confirmation because I did not add the configuration to do it automatically. That should be a dash auto approve, and it goes by itself. It doesn't require any confirmation. Okay, so let me show, while this is still deploying, let me go to my Azure subscription, and this is where I want to deploy my new resource dashboard. And I created this dashboard in my subscription, my panel, and these are the resources we have today in my environment. Now I'll return to my apply, and it's still thinking. I'm sorry for that, it's taking too long. I will leave it that way because the simple thing I want to show you in the end is that we have already created a Wagner reactor this date in the end. So I will leave it as it is and move on with our presentation because, as I said, I have a lot of slides to show you, and this is the most simple thing we can do with Terraform. Anyways, let's go. I'll go back to my. Okay, so let's go on. Now we're done for this. Okay, we deployed a new object. Actually, we're already deploying it. And one very important thing we have to keep in mind is that once you deploy your resources, once you execute your project, you will see new files in your folder. Let's see. We have the main.tf script that we are just executed. But now I see a new file, Terraform TF state, and this Terraform lock HCL and another folder in here created for this deployment. What is this? Okay. TF state is the file that controls the state of your deployments. So it's of utmost importance to keep this file there and never touch it. Don't change it, don't delete it. Please never touch it. This is how Terraform controls what it has to do. Okay? To go into more details, let's check something here. We have to keep in mind how to change or delete resources using Terraform. And see what we have here. As I said here, TF state is key. Since you're gonna run your scripts and you have already did it once, I will run again. What happens? If your script didn't change, nothing is deployed. If your script changed values for the variables, some resources will be updated with the new values you're passing. If you remove a resource from your script, this resource will be deleted. No matter what you have, it will be deleted. And if you lose your TF state, a new resource will deploy as if there was no other created. So you may get an error message in this situation if the name you're using already exists. So it's very important, one, keep attention to the TF state files. And two, save your scripts and your projects and TF status within in a place where you can share this information with your entire team. Otherwise, you may get some problems because the TF state in your machine won't be seen by people that work together with you. So keep that information in mind when you start working with Terraform. You can share information, but please pay attention to the details and do it properly, okay? Moving a step ahead, before moving a step ahead, let me see if I already finished my deployment here. Okay, it's identified. I am creating a new resource called RG, and the name for the object to be deployed is this. One object will be added, no object to change, and no one to destroy. Is that okay? Yes. Deployment started, and now we can return to our scripts. Then we will check the existence of this object with this name, Wagner Reactor, in my portal. Okay. So I will continue in here. Oops, I'm sorry. Look to the wrong place. This is the one. Okay. Very good. Okay. That said, let's go to a better strategy to work with your scripts. You have to keep in mind when you start creating your object with Terraform, you won't be creating a couple of objects, one or two. It will probably have dozens of objects in your portal. And to create a script to accommodate all those resources will be a nightmare. Nightmare to write, and even more to deploy, to update it, to change it, to debug it. So a better way to do things is to try to improve the manageability of your project and your scripts within. Okay. In a way that you can escalate better. For instance, if I have to create several databases in my machine, my server, how can I do that in an easy way? I won't go into the for each loops to create those kinds of objects, but you have to know that they already exist there. And another point is to improve reusability. Keeping considering you probably must create development environment, test environment, QA, and production. You have a script you can deploy in all those places, just changing the values you use for each one. For instance, my production environment must be a lot stronger than my dev environment. I have to deploy a larger server from my production environment. Of course, you won't spend money on that like this. So how can I accommodate all those needs in my script? So the idea is to split your script into several different types of scripts. And I'm just showing here the most basic ones. First of all, you will have a main DF script or root DF script. You can call it whatever you like. It will work the same way. Where you define your providers and resources that you want to deploy. Then you can have a separated variables file where you define the variables that you are using in your project. Then I can define another locals DF. This is a special file where we define, let's say, composite values. Let's say I put together several values, several variables to create a new variable. I don't do this in the variables DF file. I usually go to the locals DF and create this new variable there and separate the definition of variables to the creation of generated variables. Okay. You also have an output TF file when you have to export values that are generated during deploy. How can that be useful? I'll tell you how. let's suppose I create a Synapse workspace, and then I want to create a SQL pool. Good. Once I create my Synapse workspace, it will generate an ID that I need to know to to add to my scripts when I'm trying to create the SQL pool within that workspace. So I have to output this ID and reuse it in the other module that I'm creating. Okay. There are a bunch of other kind of files we can create. For instance, files to pass values. This is the kind of thing I did in my own example. I'll show you guys after this. And then there's another topic that is extremely important, is to create modules to deploy each kind of resource you can deploy within your provider. The idea behind the modules is that you create a library where you encapsulate the required syntax to deploy your objects. And you can abstract that in your own scripts. You just call the module. The module has exactly the same sequence of parameters you have to pass to deploy the resource, but you don't have to bother with this in your own script, because just changing the sequence of variables might have a wrong effect when deploying. So I don't have to bother with that anymore. I put in the modules. Okay? One more thing about modules. As I said, we use them to isolate the syntax of resource deployment required for each resource for deployment. But also, this is a shared library all your entire team will rely on to create their scripts. And in a way, you're helping defining a standard to be used within your company, because you put aside some things that may be changed if some people start creating things without any kind of methods or a framework. There is a very important thing in here. Suppose your provider is updated and then a new parameter is added to your resource, and this new parameter is mandatory. You don't have to change your script. It's optional. Let's say it's optional. Okay. You don't have to change your script. So simply add this optional parameter to your modules and keep working like it is. Because if you don't need it, if you don't use it, it won't be needed. You can abstract those requirements. I don't need to know where this new parameter is inserted in the syntax. I don't have to bother at all. I simply pass a value for this if I want to use it. That's it. I'll go again to the deployment that was running behind here. Okay, we deployed it, resource completed, and now I'll show you in the portal. No, there was a value resource loop in here. Okay, this is not the one I wanted. Jesus Christ, just a refresh is slow today. I'm terribly sorry of this. I don't know what to say, but it was working properly the entire week. Today, as we are in a hurry, there's some problem here. You see, this is the resource that we just created. It's working fine. I can create whatever I want in here. It's ready to go. Okay, let's go back to the presentation and discuss more details around how to use modules. And this is very important. This is something that took me some time to get used to when I started working with modules. Okay, it's not that I'm a very skilled professional using Terraform. I am not. I'm more a data engineer trying to do my first steps with Terraform. I can deploy some things, yes, I can, but I don't, not an expert. Okay, and this took me some time to get used to. When you organize your project with modules, you have to keep in mind you will still have your script in here somewhere, your project, and this project will be associated with a module or several modules in your library. And again, oops, I'm sorry. Go back. And again, you see, in my modules, when I talk about resource group, I have three. Jesus Christ. I have three scripts here in the resource group, in the module for the resource group. And then when I come back to my scripts, I have five scripts in here, but the important thing is to know how they work together. And this took me some time to understand. I will try to show you how I finally learned to work with them. Okay, so let's get started here in the modules folder. What are those values presented here in the left when I'm defining the resource group in the model? This in pink is the precise syntax required by Azure RM to deploy a resource group. And they have to have those names and follow this sequence of parameters. Okay, that's nice. What's next? Well, I have some vars in here, but the vars have different names. What are those variables for? Okay, this is very important to know. Those names in here are defined also in the modules variable script. And RG name, location, and text. These are just the only one different, but those are the variables that will receive the values I'm passing to the module. Okay? This is an important thing to keep in mind. Down here, just for the record, I created an output file in my module to export some information I think there might be useful, like the resource group name. This is I had in my script, but I put there anyway. And most important, the resource group ID, which I will have to have several times when I deploy other resources. So this is created in deployment time and does not exist before I run my script. So I have to collect this information from here. Okay, let's go. Just checking that we are on time. Good. Okay, so let's see the other side of the information we're working with. Those are my scripts. And how are those scripts configured, let's say? Okay. First, in in my main script, the root TF, I again define the providers I need and the resources I want to deploy. In here, I'm showing where to find the module where I have the definitions for a resource group. It's in here. And then I have those variables in here. Actually, source is not a variable per se, but just keep in mind we're looking at the other names here. RG name, location, and text. If you remember, those are exactly the names I have in the variables in my module. Or if you like, the names of the variables in the left column in my script will be the names of the variables in the right column in the module script. It sounds funny, but when I realized this, it turned to be a lot easier for me to write those scripts. Then let's move on. Now we have the names to the right in my script. Where are they? First, we have a var location, and you will see var location in here, defining the variables here. And we have two local variables. Local variables, as I mentioned, are, let's say, derived variables. Variables derived from other variables. And in fact, this is something that we have in a separate file that is the locals TF. And I'll show you now what to get. Now you see the link here, and we also have a link to another file that is locals. Let's go. First of all, we have the locals here are gname1. You see, you have a definition with including formatting, necessary formatting. Text, you have a composite variable. Actually, it's a JSON in here, and you created this JSON variable like this, as I'm showing you here. And the values I'm passing to this locals and to my main script are placed in a file called auto-tfvars. The only reason why I put this Z underscore in here is to put those files in the end of my list. That's all. I think would be easier for me to handle if the auto TFRs were separated from the other ones. And this is the way I thought would be easier to do. Anyways, company, I pass a variable WWI var company. I define var company in my variables file. And I'm using the values in here to create a new variable. Project, same thing. Cost center, here it is. Let's go to another one. Resource group identifier. It's used resource group identifier. Oh, guys, I didn't notice this. There's a simple error in here. There's a typo. Resource underscore I instead of resource group and case I. I'll have to change this in my when I share with you guys the slides. Anyway, this is the whole idea we have around the TFVars, auto TFVars, locals, variables, and main script. Let's go to another demo in here. Now we're still on time. Actually, I'm kind of 5 minutes behind. Let's go very fast to second script, and here we have, okay. You see, we have locals, we have roots, we have variables, and we have two Z files that are auto vars here and here. I create them separately so I could deploy all of them. Okay. Again, in root, I put the provider, define. Now I define two resources. Oh yeah, good. But why do they have different names? Well, those are the names I'm using within my script. I have two of them, so I'm using resource group 1 and resource group 2. But I'm calling the exact same module, and I'm passing the exact same variables, just changing the values to pass for each one. Local origin name 1, local origin name 2, var location 1, var location 2. That's all. That's all I needed to do. In the variables, I would have to define all those guys here, and then we will pass the values in the resource group, the auto vars. Here we have. Okay, I'm spinning up some things here because I want to go to the real deal, deploying several objects, so we can see what we have. In fact, when deploying several objects, that might take some time, and it really does. And I prepared this earlier, and I deployed my project so I could show you guys, and I'm do some changes now. Okay. So let's try to work with multiple resources. There are a couple of things you have to keep in mind when working with multiple resources. One of them is that I hate to say that, mainly because I am a Microsoft employee, but guys, why in hell we have different naming conventions for each resource in Azure? This is a nightmare. For instance, storage account don't accept dashes or case uppercase. Others doesn't support underscores. It's a nightmare. So I'm sharing with you guys a link with naming convention for all resource we have in Azure, so you can properly name your resources when creating your script. Otherwise, you won't be able to do it. It's a nightmare. Unfortunately, that's the way we can put the thing. Then there's another important thing, and this is, we can't avoid it anyway, is that each resource you deploy has a scope. And some resources has a global scope. So you must make sure your name is not used anywhere else in the world. And how can you do that if you don't have control what people are using? And this is a very important thing, and we will add, we'll show you some tricks here to work with that, okay? Another point, there will be many times when your resources depend on the creation of a previous resource. I can't create a SQL Server database, Azure SQL DB, if I don't create a server. I can't create a server if I don't have a resource group, and so on. I was saying talking about the example of a Synapse workspace before. This applies to everything. I can't create a container if I don't have a storage account. That's very common. So we have to keep that in mind when creating your scripts, and use something to handle this. And that's what we're going to see in the following slides. And another point, important point, and I decided to put that information in here, is that if you need to use different providers inside your project, you can do it. Oh, I'm deploying only Azure resources here, and I'm using Azure RM provider to do so. So why should I use another provider? I'll show you an example. Okay. First of all, let's begin with the unique names. A very simple way to handle this: insert a random values into your resource names, so you can minimize the risk to have duplicated resource names within your deployments. Okay, so it's very simple. You can use, for instance, this resource random integer. I called it rand, and I'm saying that it should be between 1 and 99. Well, 1 million minus 1. That's it. So it's a very large number, 6 figures. And I am using it here to add this random suffix to my resource name. I'm pointing to the wrong side, I'm sorry. I'm using this, we have three screens with the same thing, and I just lost me here, I'm sorry. So this random suffix here, I am formatting it to have 6 figures, so I will add zeros to it. And this new string I will add to my resource name as a suffix, the random suffix, and I put it there. Okay. So you can handle your unique names with something like this, and how large you want to put it, anyways, and that will do. It's a simple solution, but it works. Let's go to the other point: dependencies. Well, we can handle dependencies with things like this. You see, we to deploy a SQL pool, I have to know the workspace ID that was created before. Okay, so how should I consume this resource ID? First, I have to export it using the output that we have in the modules. And the name ID is used for this new variable. And I can then reuse it in my main script, pointing to module, Synapse workspace, and bring the output ID. So it's working fine. Awesome. But that will not do. This is not the only thing we have to do. Because why? Because those deployments will run in parallel. And there's a possibility we start trying to deploy a SQL pool before you finish deploying the workspace. So what should I do? That's it. I add depends on module Synapse workspace. This means please serialize the creation of Synapse SQL pool after deploying Synapse workspace. That's it. Finished. Okay, so let's go to deployment. When you execute the Terraform apply, it will reuse a plan that you already saved or it will create a plan to deploy your resources. And as you can notice in here, I don't not quite sure you can see the numbers, but some resources will take a while to deploy. For instance, in my example here, when deploying the Synapse workspace, it took in total 4 minutes and 49 seconds. When I tried to deploy a SQL poll, it took 2 minutes and 54 more. And so adding all those steps, it will be a longer, quite long deployment, because as you can see here, I have deployed 17 resources. Wow, 17 resources. Yes, that's it. And I'll show you in the example in here. We wouldn't have time to deploy all that online, so I will show you what I did. Okay, that's it. Source groups. Okay. As you see here, this is the resource group I deployed earlier with that the Terraform one that I showed you. You see the name here, 563645. I added it to all the resources that I'm deploying. And I deployed CosmosDB account, a Databricks account, a Key Vault, SQL Server, a Synapse workspace, one storage account. This is in fact a data lake. You see the DLLK here. That is its hierarchical namespaces. This is a regular storage account. Then I created another storage account that is used within Synapse. You see the scene here. Then I created a SQL database. Then I created a dedicated SQL pool. Okay, but I don't see 17 resources in here. Yes, you don't. But you have to remember that to create the SQL database, I had to create a SQL server, virtual server that is not here. I'm sorry, it is in here. But another example, Synapse. When you create a Synapse, you have to add objects there within. So I have to deploy an internal data lake that will be used. I have to deploy other stuff that are necessary to this. And this is the same thing, for instance, for CosmosDB, when I have to deploy the databases that are inside, when I have to deploy containers in the storage accounts and things like this. All that together will totalize the 17 resources I mentioned. Okay, very nice. But show me something here. Okay, I'll show you Databricks Synapse. And this is the example I intend to show you online. When I created this resource group, I deployed, I'm sorry, oh, still opening. I deployed a cluster within my Databricks workspace. Oh yeah, yes, I did. Here it is, DBC cluster 2. Okay, good. How can you prove me you created this in here? Okay, I'll show you. And this is the change I want to do. As you see, I have a bunch of files in here. Actually, I didn't say that before, but I'm gonna share all scripts I showed me here in the PowerPoint too. I will share in my GitHub, and the link is in the end of this presentation. Um, and so let's go to my Databricks cluster. Go here. The DBC cluster 2. Okay, this is going to be DBC reactor. Control S. Save. Okay, so let me do things again. Now I have to move to CD example 3. Oh, there's a typo. Sorry. Example 3. Terraform init. We're about to end here. This is the last thing I want to show you guys. Won't need to wait for too long. I'll try to apply it right now just to make sure we don't spend too much time on this. It will take some time to validate the entire infrastructure we are creating. We have already created in Azure, but you see, again, it recognizes I use this random value for that deployment. How does it do so? It's in TF state file. All this information is TF state file. That's the reason why I can reuse the random number I used in my first deployment. Okay. It will notice that there is only one resource that was changed. So it will leave 17 resources untouched, one resource to be changed, and no resource to be deleted because I didn't do anything at all here. Just change the name for that DBC cluster. One important thing I would like to show you before I go to the end. Here, where's this? Simple 3 root. I guess this is it. Okay. I created a module Databricks cluster that is in my modules library. And there is one very important thing in here. And let me show you in the modules. There's a small difference in here. Let me put a little bit down. In my module for this resource group, I'm sorry, in my model for creation of Databricks cluster, I didn't have a resource in Azure anymore. You don't? No, I didn't. I don't have. So how can we put this together? I can use the provider Databricks because Databricks provide some logic to do that, and it's again in the same links I showed you before. This is the link for another provider, but the same idea. And I have some information that I needed to add here to validate who I am, but I'm using a different provider and receiving the same kinds of variables I showed you in the beginning to deploy this resource. While we were speaking, it already noticed that we have nothing to add, nothing to destroy, but we have one element to change. And I'm going to execute this change to rename the server, the cluster we have in Databricks. As you see, we are working with 2 different providers at the same time with no extra problem. Actually, there's some the important thing here is to correctly authenticate each provider so it can use your resources. That's the main thing you have to keep in mind. It's still deploying. I will move on so we can spend more time on this, okay? And then we will return, when you finish, we will return to Azure Portal to check the name we have there. Okay, this is it, okay. So let's summarize what we saw here. First, there are several ways you can work with Terraform to deploy Azure resources. I'm just trying to show you guys the most simple ones. You can go a lot deeper with this, just scratching the surface of the things. It's a level 100, as I said, presentation. And therefore, we can do a lot more than we are seeing in here today. And other thing, principles I presented here can be applied to any provider you want. As you see, I use the same ideas and the same structures to include a new provider for Databricks. Yeah, but you add it to the module. I added it to the module because I'm lazy, because I should split this to another file in my main project, define a second provider, and call that module the same way I did for any other. There's no real need to do the thing the same way I did. I just saved time because I was late. Simple as that. There are several open source projects to add features to your Terraform implementation. One of my favorites is this TFSec. It stands for Terraform Security. It validates the security aspects of your scripts, what you should improve to have a more secure infrastructure. This is really nice to have. Okay? And now I'm sharing with you the link in here for this project. We have a lot more than this, but just check the documentations. You will see a lot of things that are really awesome. And to finish things, I would like to share this screen with you guys. All the scripts I showed here are available in this link I'm showing now. GitHub.com, my name, articles tree, main, Azure Terraform. And those are two articles I wrote last year about the same things I'm talking to you now. Okay, I intended to add more articles to that series, but I didn't have the time so far. It's been almost a year. It's a shame, but I don't have the opportunity to add more things. But it's available there. If you like to see more details, then you can see 1 hour workshop. Maybe you can check that information too, and you will have other resources. Just to finish things, let's see okay, deployment was done. Let's go to workspace. Aha, it automatically updated. We already have deployed and renamed the cluster we had created for this implementation. Okay, that's all I wanted to show you guys. I'm sorry we went a little over our schedule, but thank you so much for taking part in this presentation. And if you have any questions, you have my contacts, so you can send me questions if you like, or take the opportunity to ask now.
Hi, Wagner. Thank you so much for this presentation. We have a lot of questions in the chat. If you want to answer maybe a few, I'm not sure we have the time for all of them, but the rest that didn't get any answer, feel free to send an email to our speaker for today?
I would prefer you guys to send me by email because I'm not seeing the chat right now. I'm sorry for that. I didn't connect earlier. Sorry for this. But you have my contact here in LinkedIn, and also my email if you like. Please send me your questions. I'll reply to everybody that wants some guidance in here. I would be very happy to do that. Thank you so much.